Extrusion is one of the fundamental shaping process similar to a metal, and you can make the plastic also extrude with the extrusion process. Here they will mention the word extruded for extrusion of a plastic, whatever the byproduct which is obtained by polymer during extrusion process is called extruded. Okay, here also I am going to get a continuous product. Okay, here also I am going to get a continuous product as you see in your metal extrusion process. It is a compression process. Extrusion is a compression process in which the metal or the polymer, the polymer will be in the form of a pellet. Pelletனா ஒரு இது மாதிரி இருக்குது, சின்ன டேப்லெட் மாதிரி இருக்குது. Or they will have the plastic material as in form of a pellet or in the form of a powder. Okay, this extrusion is a compression process in which material is flowed through a die orifice to provide a continuous long product whose cross section is determined by the shape of the orifice. Okay, as whatever the geometry present in your die will be your final shape. That's a simple word you can see in extrusion. Okay, it is a compression process in which I'm going to send a polymer material or mostly a thermoplastic is used. Mostly a thermoplastic and elastomer is used. Elastomer is nothing but rubber, but we don't concentrate the elastomer here. We are going to concentrate only on polymer, that is plastic material. Extrusion process is a compression process in which the polymer or in which the pellet, the plastic in the form of a pellet is flowed through a die. Orifice. Here they mention as a orifice. Instead of nozzle, they may mention as a orifice. Instead of die, instead of nozzle, they will say as a orifice here. Okay. Mostly the thermoplastic is used as a raw material. Here the thermoplastic, that is the plastic permanent, you can reshape that plastic, that is thermoplastic. Whenever you heat, it will I can change the plastic, it will not degrade. Okay, here I can make the product like pipe, tube, structural shape, hose, sheet, flame, continuous filament, and coated wire, electrical wire. These are some of the application of your extrusion process. I can make a pipe, tube, hose, structural shape, sheets, sleeve, and continuous filaments, and coated electrical wire. Okay, this is the application of your extrusion plastic process. Here you have to mention whatever the extruded product is called extrudate. Extrudate. Whatever the extrusion process you are using is the extrudate. Okay. I will show the diagram so that you can easily understand. But in exam point of view, diagram is very important. In exam point of view, diagram is very important. I'll show the diagram in the next slide. This is a diagram of component and features of your single screw. Okay, single screw extruder for plastic and elastomer. Okay, this is a diagram showing your extrusion machine, which is having a single screw. Okay, it is a compression process. I'm going to have the pellet. This is feedstock. This portion is called the feedstock. Feedstock means where I'm going to put your raw material. The raw material will be in the form of a pellet. They have mentioned in polymer the feedstock in a pellet or powder form. Okay, pellet or powder form. It is fed into the extrusion barrel. It have two things. One is called the barrel. Okay, this is called the barrel. This whole portion is called the barrel. This whole portion is called the barrel. Okay, here I'm going to see some of the parts. That is nothing but hooper. The hooper is like your whatever the hooper available in your rice mill machine. Whatever the hooper available in your rice mill machine. Here only I'm going to place, or I'm going to put your raw material, that is nothing but the polymer in the form of a pellet or in the form of a powder. Here the plastic pellet, I mentioned that it's a plastic pellet. Okay, here only I'm going to put the pellet from Cooper. Okay, from Cooper. The pellet will be the polymer will be in the form of a pellet or in the form of a powder. Okay, or in the form of a powder. Here, this whole feed section is a section where I'm going to feed your raw material, the plastic in the form of a pellet or a powder. Okay, from the after that I'm going to heat this pellet or your polymer material by means of some heater, electric heater. Okay, that will somewhat that will melt your polymer material or a pellet. Hello, can we start some network problem? Can we start the session? Okay, I'll share the screen. Hello. Okay. This is the component and of your injection, compression, extrusion molding machine. Okay. Here we can see that in a feedstock in the hooper, I'm going to put this pellet or raw material in the form of a pellet into barrel. Barrel is nothing but this whole section is called barrel. This whole section is called the barrel. The barrel compressed upon a screw. Okay, here they are mentioning a single screw. This screw only makes a compressive action. It will compress and it will melt your, due to this compress, it is rotating. Due to this rotating action, the polymer material will melt. Okay, polymer material will melt. Okay, due to rotation of the screw only, the polymer material will melt. Before, after pouring that pellet, I'm going to melt or I'm going to preheat your plastic pellet by means of this electric heater. There will be electric heater will be provided for melting your or preheating your pellet. After preheating, this screwing action will provide a compressive action also, and it also melt that the heat generated by reciprocating action or screwing action, revolving action, that also provide heat for melting your polymer material. Okay, this whole section is called the barrel. This whole section is called the barrel. Then I'm going to the slide. Okay, there are two components here. One is a barrel, another is a screw. Okay, this is a barrel. Whole section is called the barrel. Then it's a screw. Okay, whole section is called barrel. It's a screw. Here, preheating is done by a heater, some electrical heater that will melt your partly that will melt your that pellet or the polymer in a plastic form. Okay, inner diameter of the barrel will ranges from 25 to 150 mm. Inner diameter, okay, in the inner diameter of your barrel will be varying from 25 to 150 mm in diameter. Okay, L by D ratio. L is nothing but the length of the machine or length of the barrel. Length of the barrel. D is nothing but a diameter of the barrel. That is inner diameter of the barrel. Okay, it will be in the it ranges from 10 to 30. 10 to 30. Normally, length of the barrel is 30 times. Okay, length of the barrel will be 30 into D. Okay, 30 times inner diameter. Okay, it will be 30 times longer than your inner diameter. 30 to 10 times longer than your inner diameter. Okay, Hopper already discussed that it is located at the one end of the barrel opposite to the die. Where is the die? I will show in the diagram. This portion is called the die. This portion is called the die. Okay, here they will use a word, not as a mold, they will use a word die. uh, Whatever the cross section of the die will be your final product. Whatever the shape in the die will be your final product. Whichever the product coming out is called S2 date. S2 date. Whatever the shape of the die will be your final product. Whatever the geometry of the die will be your final shape of the final product. Okay. Who the pellet are feed by gravity. Okay, you know that I'm going to pour the pellet through hooper, and it will flow by gravity. That will flow by gravity. That is only mentioned in the slide. That is feed to your rotating screw. Okay, that moves the material along the branch. That will move your pellet along towards the die or towards your barrel. And earlier I mentioned that I'm going to use a electrical heater to melt the solid pellet. Okay, further the melting it happens by the mechanical work done by your screw. Okay, the rotating action done by your screw. Okay, I'm that is that the screw is rotated at 60 revolution per minute. As per your screw is rotated by about 60 revolution per minute. Okay, screw is rotated by 60 revolution per minute. That screwing action helps to melt. It will do your mechanical mixing also, and it will provide heat for melting the pellet. Okay, it will do one operation, that is nothing but mixing operation, as well as mechanical mixing, as well as the screwing will provide heat for melting your molten, sorry, melting your pellet. Okay, that is only there are three sections as mentioned in the diagram. First section is nothing but your feed section. Second section is nothing but compression section. Third section is nothing but a metering section. Okay, feed section is nothing but where I am going to feed your pellet and pre-melting of your pellet by means of a heater. The compression section is nothing but you are going to compress your pellet, and by mechanical screwing action and proper mixing of your pellet also take place. Metering section is nothing but I'm going to align because your raw material or your material is having a rotary motion. I have to make to be a straight motion. Okay, I have to make that rotary motion to a straight motion. That is done by means of this breaker plate. The rotary motion of your product, that is pellet, is converted to a linear motion, that is straight motion, by means of this baker plate. Baker plate is nothing but it consists of sieves, salad consists of sieves that will help to and the first thing is that will make that rotary motion to a straight motion. That breaker plate will help. Otherwise, here after here, I need only a linear motion. I need only a linear motion. If the rotary motion is not happened after this one, it will affect your die. Okay, it will affect your die, and you will not get your final product because it will rotate means you will not get your final product. After this breaker plate, you should have a linear motion. For that only, I am having a breaker plate. That breaker plate help to convert this rotary motion of your raw material, that is your pellet, into linear motion. Breaker plate is nothing but a sieves. You have a sieves that will break the lump portion of your pellet also. That will break down the lump. Lumpna கட்டியா இருக்கிறத ஃபுல்லா உடைக்கும். Okay, அப்புறம் any other foreign material வராம தடுக்கும். Okay, that is a function of your breaker plate or sieve. Okay, that is mentioned in this slide. Okay, okay, for getting a homogeneous mixture only I need this that is a breaker plate. Okay, breaker plate. The next slide will show what is the function of your breaker plate. That is a screen pack or breaker plate. It's called a screen pack. Before reaching the die, the melt passes through a screen pack, a series of wire meshes. Wire meshes is nothing but another or cylinder supported by stiff plate, that is nothing but breaker plate. Okay, containing small axial hole. It will filter the contamination and hard lumps from the melt. Okay, it will prevent the entry of any foreign material, or it will break the hard lump. அதாவது கட்டியா இருக்க மெல்ட் ஃபுல்லாக உடைக்கும். Okay, build up pressure in the material state. It will straighten the flow of polymer melt and remove its memory. Circular motion வந்து என்ன பண்ணும், மெமரி வந்து அதை வந்து convert to a linear motion. Okay, it will convert to a linear motion. That is a function of your breaker plate, or it's called stiff plate. It is consists of a series of wire meshes. Okay, it consists of series of wire meshes. If suppose I'm not making I'm not converting that rotary motion, means it will affect your die and it will affect your final product. Whatever the product obtained will be in the form of a twist condition. Okay, வளைஞ்சு வளைஞ்சு கிடைக்கும். இந்த ஸ்ட்ரெயிட் ஆக்கலைன்னா, அந்த ஸ்ட்ரெயிட் சர்க்குலர் மோஷனை வந்து நான் ஸ்ட்ரெயிட் மோஷனை ஆர்க்கலைன்னா, the final product will be in the form of a twist condition. அதாவது வயர் மாதிரி வளைஞ்சு வளைஞ்சு கிடைக்கும். முறுக்கு எப்படி கிடைக்கும் அது மாதிரி கிடைக்கும். அதாவது அது வந்து is a defect. Okay, so only I am making the rotary motion of a screw, which is obtained by a screw, into linear motion by means of a stiff plate, or called breaker plate. Okay, that is a function of your breaker plate or stiff plate. It may be asked for your 2-mark question. Okay, that is a function of your breaker plate. It is a working of your extrusion molding machine. Okay, extrusion molding machine. Once again, I repeat the extrusion molding machine. Okay, it is a compression process in which the polymer in the form of a pellet is forced to flow through a die orifice in order to get a long continuous product. With whatever the product obtained is called the S2 date. Or the final shape of the S2 date will be whatever the geometry present in the die. Mostly I am going to use the material thermoplastic. I am going to use the material thermoplastic. Application of this material will be in the form of a tube, pipe, structural shape, sheet, and thin film coated wire, electrical wire. Okay, here this extrusion machine consists of two important components. One will be called barrel, another will be called screw. One will be called the barrel, another will be in the form of, is called the screw. Okay, here I am going to put the raw material, that is polymer material, through hooper in the form of a pellet or in the form of a powder form. That will flow into the barrel, and it is heated and melted and forced through a die by means of a rotating screw. Okay, here I am going to use the raw material in the form of a pellet, and is forced and it is heated and melted and flow through a die opening by means of a rotating screw. Okay, here the die is also not a part of your extruder product, extruder, because I have to use different die for different product. I have to use different die for a different product. Next, we come across the diameter of your barrel. The inner diameter of the barrel will varies from 25 to 150 mm. L by D, that is nothing but length of the barrel divided by diameter of the barrel, will be in the ratio. They will be in the range, will vary in the form, vary from 10 to 30. Mostly thermoplastic will be used. Okay, here I am going to preheat your pellet by means of electrical heater. Okay, it will the pellet will be melted, or it will be partially melted by means of a heater. Then the screw will provide a compressive action. That is nothing but it will provide a mechanical machine as well as it will provide a heating action, and it will melt your pellet by means of this screwing action. This screw will rotate in in the range of 60 revolution per minute. Okay, once before reaching the die, there is a plate called a breaker plate. It is nothing but a stick plate. They have a series of axial hole. That breaker plate will convert this rotary motion into linear motion. That is rotary motion of your pellet into linear motion. That will convert and it also removes the lump lump amount of pellet, other lump quantity of pellet as well as any contamination. It will also provide some compressive action here. Okay, this is a function of your working of your extrusion machine.